The next thing I want to talk about here is typical sedimentary rocks. And I mean, I'm really glad we did the crystal things because we're going to keep referring back to this thing over and over and over again. And this is basically going to be a test question. I'll tell you that right now. This is a test question. How do we get evaporites to form? And if you think back to what we did here on these, that'll be a lot easier to describe and for you guys to remember that process. Basically what happens is you have this ocean, and this ocean has like nearly limitless amounts of water in it, really. It's just a whole bunch of water. And the more water you have, the more that the ocean can keep in dissolved state, right? So keep all those ions and minerals in solution. Well, if I just take the ocean and I somehow put it into a restricted basin, so think of it like a lagoon or something like that. Now I don't have a tremendous amount of water. So remember, this is where we took the magnesium sulfate and we dissolved it in your little beakers, right? And then you pour that beaker into here. As soon as you poured it, you didn't really see any crystals, did we? But now that's in a restricted space, and that water slowly evaporates, now all of a sudden we can't keep those minerals in solution anymore, and so they start to crystallize along the bottom. And that's basically what we have right here. So in creating these crystals, we actually created evaporites. And those are examples of sedimentary rocks. When we look at this aurora chalcite, it's beautiful mint green, it basically was deposited the same way, where the rock was inside this really hot water, completely submerged, and then either as the water cooled or as the water slowly drew away, those minerals started to fall out of solution and crystallize on the rock surface. And so that's basically this process right here. And a lot of times we get really interesting creations with that. And some of you guys maybe have seen the special from National Geographic where it creates the crystal cave, the giant crystal cave. You guys seen that one before? Or am I the only one that's crazy enough and watches this stuff?
We'll have to do it.
I've been trying to get a video of it and they don't sell it anymore.
That makes me mad.
No. Does it? So basically when we look at evaporites, it's typically going to be 1 of 3. Usually calcite, gypsum, and halite. Those 3 examples are basically, examples of chemical sedimentary rocks that we get. On that note, let's bring this up. On that note, yeah, Tanner, we need your help. We're going to pull this right from the front. Yeah. Now, when Tanner's holding up here for us, oops, everybody can see. We're blocking off the whole half of the okay. So what Tanner's opening up here is a map of Michigan. This is the geologic map of Michigan, showing the bedrock. But now this is really interesting when we talk about this, especially when we talk about the restricted basin. In the region of Alpena and Tawas up here, as well as some other areas on the other side of the state, we have large deposits of gypsum. Why? Chris? Go for it. Okay? I would normally say yes. All right, with the Great Lakes right there, it kind of makes sense, doesn't it? Well, the problem here is that normally gypsum is going to be from salt water. Okay, so I had to have been an ocean at one point? Gabby? Okay. Well, how many guys have seen pictures of basically submerged mountaintops called atolls out in the Pacific Ocean where they're surrounded by a shallow reef? They're literally the top of the mountain is just below the surface. Okay? And normally with that, there's a small little tiny inlet that lets out ocean water in, and then we get a lot of evaporites that form. When you look at the state of Michigan, the Saginaw Bay region, there's a reason why it still has that shape even today. That's the old inlet. So you can think about this whole thing having this huge arc. You guys remember the Niagara Escarpment? Keep going back there. That's the actual reef. That's how big this thing was. It was huge. It goes all the way up to Niagara Falls, back across to the UP, back down through Wisconsin, and right back down through here by Fort Wayne. So this little piece of Michigan is the original inlet for that reef. And as that ocean water was coming into Michigan, all those minerals and stuff get dispersed, and they slowly start to fall out of suspension along the outsides of the reef. And so we get large concentrations of gypsum over here, as well as on the far west side of the state. So it's kind of interesting. A little bit of local geology for you guys.
I have a question. How far is Toronto from Detroit?
It's quite a ways.
Is it?
And since you guys have not seen pictures of the giant caves, no, that is not photoshopped. Those are large crystals of gypsum. Again, what is gypsum made into? No. Drywall, right? It's that white powdery mineral that's in drywall. All right, the last type of sedimentary rock I want to talk about today is organic, and again, that's basically made from fossils, right? So dead living, or things that used to be living, not dead living things, doesn't make any sense. And basically limestone, that's the one you guys need to know. So we have tons of fossils, and what's really interesting, do you guys understand what the fossilization process is? I'm going to send this around. This is a nautilus shell. And what happens in fossilization is the calcium that's in your bones gets turned into calcite mineral. And when you look at this, you can see the yellow crystals. That is literally the bones or the calcium that was within the shell of the animal getting turned into rock. And that's what fossilization is. We take all the calcium that's within the living creature, living organism, and we turn it into rock. And if you look really closely, especially in the first couple of shells, or the chambers, you'll see a little bit of pink red. It's a little bit of a biomass, too, that kind of fossilized with it. Yeah, I'll pass that one around.